All right, today we're going to talk about our last property, which is the commutative and associative properties. These properties can only be used when adding and multiplying. So if it's adding or if it is multiplying, these properties will work. All right, so some questions to think about. Is 9y equal to 9 times y? Well, we know that answer is yes, and we know that because anytime a number and a letter sit side by side, that means to multiply. So remember, when a number and a letter sit side by side, that means to multiply. So if I had 6x, remember that is the same as 6 times x, okay? So anytime a number and a letter sit side by side, we have an imaginary multiplication in the middle, okay? All right, same thing for the next one. Does 7 times r equal r times 7 or equal 7r or r7? And the answer again is yes. And because when we multiply, we can switch the order. So when we multiply or add, we can switch the order. Okay, think about it. If I said, off to the side, if I said 1 plus 4 equals 5, we know that's the same as 4 plus 1 equals 5. Or if I said 2 times 3 equals 6, we know that's the same as 3 times 2 equals 6. So when we multiply or add, we can switch the order. Okay? All right, and then it says, how can we check? So anytime you want to check to see if they're equal, we can plug in 2. So anytime we're looking to see if they're equal, we can plug in the number 2. And we'll see what you're talking about in the next slide. So open up your notes and let's go look at our next section. So we're going to start on the left side with the commutative property. Okay, the commutative property. So the commutative property says that adding and multiplying, again, are reversible. They're switchable. So if you're adding, if it's all adding or if it's all multiplying, we can switch the order. And it's not going to change our answer. It's not going to change our answer. So let's prove that with the numbers 7 and 4. So if I said 7 plus 4, does that equal 4 plus 7? So all I did was I took my numbers and I just rearranged them. So I took my first number and I put it at the back, and I took my second number and put it at the front. So again, are these equal? Well, we can just solve and see. So what is 7 plus 4? Well, 7 plus 4 is 11. And in the back, what is 4 plus 7? Well, that's 11. So you can see that reversing that addition did not change it in any way. And the same thing goes for multiplication. So if I said 7 times 4, is that equal to 4 times 7? Well, yes. 7 times 4 is 28, and 4 times 7 is 28. So again, we proved that adding and multiplying are reversible. So the same goes for when you have a number and a letter. Okay, a number and a letter is totally reversible as well. So if I said 8 plus y, that is exactly the same as y plus 8. And again, you can only do this when adding or multiplying. So if I said 8 times y, right, little invisible times there, that is exactly the same as y times 8. Totally reversible. Okay. A non-example, well, non-examples are going to include subtracting and dividing, because subtracting and dividing are not reversible. So subtracting and dividing are not reversible. So an example of that might be if I took, let's see, the number 10 and I subtracted 2, is that equal to 2 minus 10? Well, we know in the front, 10 minus 2 is 8. But on this side, if I have $2 and I try to spend $10, I will end up with a negative. So that's a non-example. So the same thing goes for when you have a letter. So if I had a letter like, let's do 7 divided by y. Okay, is that the same as y divided by 7? Well, no, because you remember we label our cowboy, and when we label the cowboy, that's 7, but when we label the cowboy in this one, that's y. And so again, different cowboys, different problems. So dividing and subtracting are not reversible. Okay, so the commutative property says that we can switch the order. Okay, totally reversible is the commutative property. So again, commutative is add or multiply is reversible. We can switch our order. All right, and then if we slide to the next side, we're going to talk about the associative property. So the associative property says that we can change where the parentheses go and it does not affect the answer if, okay, we're going to add a little if down here, if it's all the same operation. If it's all the same operation. So parentheses cannot change operations. So again, if it's all adding or all multiplying, we can move those parentheses around wherever we want. It will not matter. But it has to all be the same operation, and it only works, again, when we are either all adding or all multiplying. Okay? We can change where they go. So let's do an example of that. So if I said 5 plus 2 plus 4 equals 5 plus 2 plus 4. And let's say that the parentheses on this first side are at the front, 5 plus 2, but on the second one, they're at the back, 2 plus 4. So let's solve it using order of operations and see if it changes. Okay, so we have 5 plus 2 is 7, and 7 plus 4 is 11. Over here, 2 plus 4 is 6, and 6 plus 5 is 11. 11 equals 11, so we know we have proven that it doesn't matter where our operation goes, or our parentheses go, as long as it is all the same operation. So in this problem, we had adding and adding, adding and adding. Again, as long as it's all the same operation, it does not matter where our parentheses go. And then a second example we could use with a letter, right? So we have 7, 1, and R. So if I were to plug that in, I could say 7, let's do times. 7 times 1 times R is equal to 7 times 1 times R. And again, we can move the parentheses. So we'll start at the front here and we'll do the back here. And then we'll solve it and see if they come out equal. So on this side, the left side, 7 times 1 is 7 times R is 7R. And on this side, 1 times R is just R times 7 is, again, 7R. So again, as long as it is adding or all multiplying, the parentheses can move around wherever they want. But if the parentheses change operation, then that becomes a problem. Okay? So a non-example is going to be any example where we include subtracting and dividing, because remember, these do not work on subtracting and dividing. So let's say, and we cannot mix operations. So let's add that as a note. Remember, it has to be all the same operation. You cannot mix operations. So a non-example might be 5 plus 2 times 4. And in that 5 plus 2 is in parentheses. And then on the other side, we might say 5 times 2 plus 4. Again, the parentheses at the front there. So let's solve these and see if that works. So we changed the operation inside. So in this parentheses, our operation is add. In this parentheses, our operation is multiply. Anytime the parentheses changes operations, it's not going to be the same. So we're going to prove that here by solving. So we have 5 plus 2 is 7, and 7 times 4 is 28. On this side, we have 5 times 2 is 10, and 10 plus 4 is 14. So we can clearly see these are not equivalent, not equal, because they are non-examples, okay? We cannot mix operations, and we cannot use anything that involves subtracting or dividing. And that is the commutative and associative property. Go practice.